In this video, we're going to look at how many particles there are in a given mass of any chemical. So the first thing you'll need to do this is to calculate how many moles you've got, because we know that the mole is 6.022 times 10 to the 23 of anything. So just like we say a dozen eggs, we mean 12 eggs, or a dozen buns, we mean 12 buns, or a pair of shoes, 2 shoes, a pair of socks, 2 socks. A mole is a set number. We need to know how many moles we've got to be able to work out how many particles we've got. So the first thing that we do is, if we want to calculate the number of particles, we'll need the number of moles, and we're going to times it by Avogadro's constant. So remembering that Avogadro's constant is given the symbol L or the symbol Na. I'm going to use L here. We're going to times that by the number of moles we have, because 1 mole is Avogadro's constant, and that will give us the number of any type of particle that we found the moles of. So our first example says calculate the number of carbon atoms, so that's our particle, in 100 milligrams of diamond, which it says is pure carbon. So the first thing that we're going to do is calculate the number of moles by doing mass over mR, but remember that mass has to be in grams, so we're going to convert milligrams into grams by dividing by 1,000, or 10 times 10 to the minus 3. I'm going to use the periodic table to look up the AR of carbon, which is 12, and then we're going to use our calculator to calculate the answer to this. And we're getting 8.33 times 10 to the minus 3 moles of C. So our number of carbon atoms, our particles here are the carbon atoms, will be our moles, 8.33 times 10 to the minus 3, times Avogadro's constant, 6.02 times 10 to the 23. Now remember, you'll be given that number in the exam. My tip to you would be not to clear your calculator display, but to use the answer that you've already got in there and times it by Avogadro's. You get 5.02 times 10 to the 21 atoms. How many grams of ethanol contain this many molecules? So this is our number of particles this time, is the number of ethanol molecules. So 1.204 times 10 to the 23 is equal to, if we go back up, our number of moles times by Avogadro's number. So we can find the number of moles by dividing our particles by Avogadro's constant. So again, using your calculator, and we're getting 0.200 moles to 3 significant figures. Now, we want to calculate grams, which is a mass measurement, and mass is Mr. moles. So we need to add up the MR of ethanol. So if we just do that over here, we've got 2 carbons at 12, 5 hydrogens at 1, an oxygen and an extra hydrogen. That's 46. Again, you can use your calculator to do that. So we're doing 46 times by 0.2, 9.2 grams. Okay, so I've got some further examples that we can have a go at. This one says, what is the number of hydrogen atoms in 6.8 grams of ammonia? So the first thing I can do with a mass is work out moles. So moles is mass divided by MR. So we've got 14 and 3 ones. That's 17. So let's work out how many moles we've got. So that's 0.4 moles of ammonia. Now, remembering that 1 ammonia, NH3, is made up of 1 N and 3 H's. So for every one ammonia, I've got 3 hydrogens. So the number of moles of H atoms is 3 times 0.4, which is 1.2 moles. So the actual number of hydrogen atoms we would have to, which is our particle here, we'd have to times 1.2 moles by Avogadro's number to find out how many we actually have. And we're getting 7.22 times 10 to the 23 atoms. Okay, so let's have a look at another one. What about how many oxygen atoms are there in 120.2 grams of silicon dioxide? So our first thing is to turn 120.2 grams into moles. So again, using our periodic table and adding up silicon dioxide. So 28.1 plus 2 lots of 16, 60.1. So that's 2 moles. And in silicon dioxide, we can see that that splits up to give us 1 silicon and 2 oxygen atoms. So one of these makes 2 moles of oxygen atoms. So the number of O atoms equals 2 times 2, which is 4 moles. So then the actual number of atoms, not the number of moles, would be 4 times Avogadro's constant. So that would be 2.41 times 10 to the 24 atoms. You could have kept the 2.408, but I've rounded to 3 significant figures here. What about this last one? How many electrons are there in 18 grams of water? So the first thing, you've got a mass of water, so you can work out the moles. 18 grams is 1 mole of water. And then if we have a think about a water molecule, so oxygen, if you look it up in the periodic table, has 8 electrons, and each hydrogen has 1. So we've in total got 10 electrons in a water molecule. Okay, so the number of moles of electrons would be 10 times 1. For every 1 mole, there are 10 electrons. So 10 moles of electrons. And therefore, to work out the number of electrons, we would times by Avogadro's. So again, you could possibly do this in your head using the standard form, or you can type it in your calculator to get the answer.